Hello everyone. In this session, we are going to see about boundary representation. Simply, objects are represented by their bounded faces in solid modeling. So, what is meant by BREP, otherwise known as boundary representation? It is a method for representing shapes using the limits. A solid is represented as a collection of connected surface elements. The boundary between solid and non-solid, as we can see that in this image, this is the original object and these are the faces which is obtained from the original image. So boundary representation is used to representing the shape of this object. So from the side view we can able to see that this side can be represented by this. So all these faces are connected to form this object. So this representation is viewed through this boundary representation. Data structure of boundary representation. So how an object is represented through boundary representation. So topology. Topology is nothing but how the elements are connected between them. So geometry is nothing but the shapes, how the shapes are. So that can be derived from this geometry. So from the topology, the object can be identified and the object can be cut down to form bodies, number of bodies. So simply number of bodies connected to form an single object, and then genus, and then face. Number of faces are genus. Face is nothing but the connection of loops, and then connection of edges is nothing but loops, and the connection of vertex is nothing but edge, which means from top down approach we can able to understand that two vertex can able to form an edge and two or more edges can connected to form loop, and the loops connected in a closed form to form a face, and the number of faces is nothing but genus, and then all the genus are connected to form a closed object. A closed surface is nothing but body, and then number of bodies. So either an object has two or more bodies, so that two or more bodies connected to form an object, and this object represents the topology, how the vertex, edge, loops are connected. That can be derived from this topology, and each edge, each vertex, each loop, how they are formed, how they are connected can be derived from the geometry. So here you can see that same geometry but different topology. So here same geometry is nothing but here a rectangular box with inside semicircle, here rectangular box with outside semicircle, which is nothing but same geometry but different topology. Here this semicircle is reverse in this object, but in case of this example same topology but different geometry, here we can able to see that both the images are similar, but this image is little bit tilted or inclined with some angle, and so this example represents same topology but different geometry. So boundary representation is one of the most popular and widely used schemes to create solid models of physical objects, and it is based on the topological notation. So that notations forms a physical object bounded by a set of faces. These faces are regions or subsets of closed and orientable surfaces. A closed surface is one that is continuous without breaks. So a closed surface. So here V1, V2 and V5 makes a form of face, a single face. V1 and V2 makes an edge. V1 and V5 makes another edge. V2 and V5 makes another edge. So an orientable surface is one which it is possible to distinguish two sides by using the direction of the surface normal to the point, either inside or outside the solid model under construction. So each face is bounded by edges and each edge is bounded by vertices, and thus topologically a boundary model of an object is comprised of faces, edges and vertices of the object linked together in such a way to ensure the topological consistency of the model. Here we can able to see this example. So from this a triangular pyramid. So V1, V2, V3, V4, V5 are the vertices. So V1 and V2 makes an edge 1, V2 and V3 makes an edge 2. Similarly, the edges are made, and for the face formation, all the edges should be in a closed form. So here face 1. So face 1 consists of vertices V1, V2 and V5 and the edges E1, E4 and E5. So from phase 1, so here is an example, vertices of V1, V2 and V5 and edges of E1, E4 and E5. So we can able to see that in face table, edge table and vertex table. So similarly all the edges, all the faces are formed and plotted against their tables respectively. So vertex, what is meant by vertex? It is a unique point in a space. So edge is nothing but the connection between two vertices. So it is finite non-self intersecting directed space curve boundary by two vertices that are not necessarily distinct. And what is meant by face? So number of edges connected in a closed manner to form an face, that is also non-self intersecting region of a closed oriented surface bounded by one or more loops. Loops is nothing but a closed, so non-closed edges. Loop, it is an ordered alternating sequence of vertices and edges, as I said earlier in this point. Genus, it is a topological name for the number of handles or through holes in an object. So in this example there are two holes in this object, so it has genus. Body or shell, it is a type, it is a set of faces that bounded a single connected closed volume. A minimum body is a point. So this example can also be represented through Euler's formula, which is nothing but mathematical representation. So Euler points are law for closed objects. For closed objects means there will be no genus, that is no holes in the object. If there is holes in an object, then it can be considered as open object. So this is the mathematical representation for this example. So how many vertices? So 1, 2, 3, 4. So here V1, V2, V3, V4, V5, V6, V7, V8. So vertices will be, outermost vertices will be 8, and also here also it is considered as a cubes, and so these cubes holes also have vertices, edges. So these are the examples. So these examples forms a simple polyhedra, which means there will be no holes, a simple cube, and in this case polyhedra with the faces of inner loops, which means here it will be a hole and this will be a projection. So and polyhedra with not through holes. Not through holes means this hole will be inside the solid objects. So it is represented in a wireframe model, and so we can able to see the holes inside the objects. And polyhedra with the handles are holes through holes. So in this case we can able to view the holes directly in a solid model. So here F is faces, E is edge, V is vertex, L is loops, B is body, and G is genus. So these examples is represented in the table form. So what are all the advantages of boundary representation? Traditionally a popular modeling method related to traditional drafting. So very suitable tool to build quite extraordinary shapes like aircraft and automobiles that are difficult to build using primitives. Here primitives is nothing but the generation of solid through a single 2D diagram, which means a cylinder can be formed through a circle with an extrude operation. That example is nothing but primitive operation. It is comparatively simple to convert a boundary representation model into a wireframe model because its boundary deception is similar to the wireframe definition. Here boundary representation technique, how the objects are bounded or connected, that is the main representation, and so it can be easily convertible to wireframe model. In application, BREP algorithms are reliable and competitive to CSG based algorithm. CSG is nothing but constructive solid geometry. Constructive solid geometry fully based on the Boolean operation. So that can be viewed in another video. So reliable source means either it can be available as any other areas. And what are all the limitations of boundary representation? It requires large storage memory space as it stores the explicit definitions of the model boundaries. In simple manner, so it requires large storage as because of it should verify the number of vertices, number of edges, and number of edges which makes faces, and so go on. So simply it requires more storage. Sometimes geometrically valid solid models are not possible. So geometrically valid solids, that means like a circle can be made into cylinder through extrude operation. So that geometry is cylinder. Initially circle is made to form a cylinder through extrude operation. Similarly, the complex objects, geometrically valid solids are not possible in this boundary representation. Approximate boundary representation is not suitable for manufacturing application. Approximation techniques in the boundary representation will not be suitable for manufacturing application, and it can only be used to verify the objects, bodies, vertices, edges for easy clarification only. So end of the session. Next session we will see about another topics in CAD. Thank you.